dependent variable. So when we do that, the same way we go about the analysis initially, this is what we are going to do. Just click on data analysis, look for regression, click OK. Right now this is going to be treated as Y, and for the X we have the remaining independent variables. So all our things as it were, then we have the new result. So I wonder what we'll be interested in this case is just the R squared. As you can see, the R squared is 0.432723. so that particular R square is what we're going to substitute into the formula for variance inflated factor, which is simply 1 divided by the R square of the questionable independent variable. And what do we have as the R square? It is here, 0.432. So by just doing this, we get the VIF for H. So as we can see, for H, the variance inflated factor for H is 1.7. Approximately we call it 2. So if we want to talk about H, probably we just say H is just 1 times larger than what is variance is expected to be. But we can see that this is actually so small, we can asymptotically see call this 1. It's not that large, so it is negligible. So as far as H is concerned, we can say that H is not affected by multicollinearity. It's not the variable that is bringing much of the collinearity. So we proceed and check for the other ones. So now we have weight. The weight now will now stands as our Y in quote, while we have the remaining. When you follow the same process as we have done, you have the R squared to be 0.8, and in calculating the VIF, which is just saying 1 divided by 1 minus the R square you got for using weight as your Y, which is 0.88. At the time you have that calculation, you are going to have 8.47. This is a little bit large. That means we are saying that for weight, the variance for the coefficient of weight is 8 times larger than what is expected to be. I think 8 is quite a large number, but if you recall the discussion in the slide, we said whenever is more than 10, it shows that there is a serious multicollinearity. But when it's close to 1, it shows that it's not something to be worried about. But in this case, our VIF is 8. 8 is not too far from 10, so at least we can still say there is a good measure of multicollinearity as far as weight is concerned. So the next is the body surface area. If we check the multicollinearity for this, doing the same process as explained earlier, the VIF when you use body surface area is 5, which is suggesting that for the coefficient of body surface area, the variance of the coefficient is 5 times inflated than what is expected to be. So let's just quickly look at the remaining. For duration is as close to 1. There's no serious multicollinearity. For pulse is 4 times, has its variance to be 4 times inflated than what is expected to be. So I think there should be one more to this side. So for stress is 1.8. we can say is twice more than what is expected to be, and we can also see that one as almost as close as to 1. Alright, so having gotten all this, we might want to check our slide to see those results. Okay, these are the results we have discussed earlier. These are also the results. So these are the variance inflated factor. This is for the age, this is for the pulse, this is for the weight, this is for the stress, body surface area, and this is for duration. We can see basically where we need more attention is in the body surface area 5.38, the weight 8.4, and also the pulse. And if you recall that if you check this independent variable weight and body surface area, there seems to be a related factor, because when you are talking about body surface area and weight, they're almost measuring the same thing. What would be a proof? Let's look at the correlation between weight and body surface area. Body surface area, and this is 0.875. This is large. This is large. There's a strong correlation between weight and body surface area, and for us to be able to have a very good regression analysis and inference, there will be need for us to drop either weight or body surface area. And as a researcher, the choice of what to drop depend on your interest of